I don't wanna be. I do. I'm feeling goofy.
Hi, I'm Lorant. I'm also from Prezi, and I'd like to talk to you about fonts today. And yeah, fonts are difficult. So, as you know, Prezi is a presentation software, and lots of presentations contain a lot of text. And we also want to go multi-platform. That's why we are here, partially. And there's a problem with platforms and text. Right, so every platform, Android, Windows Phone, whatever, has a way to show you text on the screen some way. But there are slight differences between those representations. And while you can notice this when you're looking at an HTML page in one browser or the other, it's not a problem there because you have the box model that parts of your page resize around those differences, so it's okay. But for Prezi, it's much of a bigger problem. So just imagine that we have a user who designs their presentation on the Windows machine, and they make everything fit really nicely and align stuff. And then she pulls out her Android tablet, tries to present from that, and then it just goes like that. It did happen. It does happen a lot of the time, because right now we don't have a solution, or we hopefully have very soon. So we couldn't just have this this problem. We needed a solution, and after looking at a lot of options and a lot of ideas, we ended up having to write our own text rendering engine. But what is a text rendering engine actually? Let's dive in. And sorry about the typographic details and basics, but those are needed. So basically it's a pipeline, right? So one end goes in your font file, which is an open type font, and your text, which has formatting, and on the other side hopefully comes out some pixels on the screen of your device, exactly like on any other device. And the pipeline has a couple of steps, a few steps. The last part is not really very important to us right now, the drawing and handling the user input and stuff like that, because it's a very platform dependent issue. So we have to write some kind of platform dependent thing for it, because on a touch screen you handle user input differently than if you have a mouse, and etc, etc, etc. So let's just look at the first two steps, which can be and should be done for us in a platform independent way, and to work on every platform in the same way. So the first part is shaping. Shaping is basically, if you look at an open type file, it has two kinds of information: the glyphs, the parts of the font, for every letter and every symbol you have all the curves that make up that character basically, and the rules that define how these characters work together, how they modify the positions of other characters in their vicinity and stuff like that. And there can be quite a lot of those rules. So shaping is basically taking those rules, taking those glyphs, taking the text that you want to show on the screen, and finding out which glyph goes where in a straight line, right? So you end up with a line of these glyphs. And the next step is that you break those lines into the required width. That's basically it. And then you can apply alignment, left alignment, right alignment, etc. Okay, so once you have that, you can draw your stuff. You just need to draw some curves and fill in the spaces in between. So that's the easy part. Maybe the guys who worked on the iPad rendering don't agree, but from our point of view, that is the easy part. So this is what we wanted to create like about a year ago. Our CTO had a talk here last year, and I'm pretty sure some of you remember that he just pitched this problem as well back then. So where did we get with this problem? So the original idea was that we would expect this problem to require quite a few lines of code to solve, right? And we wanted it to solve on quite a few platforms, and if you multiply those two, you get a lot of code. We just don't like a lot of code. We don't like synchronizing between teams and maintaining all kinds of different code bases. So we wanted to have a single solution for all of this. And somebody said, nobody knows who, that hey, there is this thing called JavaScript. that is everywhere available, right? So why not try to do it in JavaScript? It has the benefit of being available everywhere, and it has benefit also that you don't actually have to code JavaScript. You can if you want to, but you can also use CoffeeScript, Hex, even C# compiles to JavaScript. So we have the choice of using any of these languages, and that's pretty cool. So why don't we do that? And then we can just code the UI on top of it in any kind of language that supports that kind of platform that we are targeting. So that's what we set out to do in the beginning. So we just sat down and started coding CoffeeScript because CoffeeScript is cool. And very soon it was unavoidable to be honest with ourselves and say that no, this is not a problem we can solve. So first we thought that, yeah, so we can now have something which supports the Latin-based languages, but we also want to add support for like Hebrew. Okay, Hebrew is right to left text, so we need to switch around some index loops and stuff like that, and we're done, right? Turns out it's not so easy. The Unicode consortium has like a 40-page documentation about how you do bidirectional text, because it turns out there's no true right to left language anywhere in the world, only bidirectional, because numbers you will always write left to right for whatever reason. Okay, we can do that. We can just sit down a little longer, and then we can do this thing. And then there's Arabic. Arabic, you need a lot of ligatures, like these combined glyphs for several characters. That's how you get this sort of handwritten feel, right? So yeah, okay, we will do ligatures as well. Okay, damn it. And as you can imagine, these things, as we thought about more and more languages to add, they just piled up, and it was apparent that we didn't have the resources, we didn't have the knowledge about the languages, and we didn't have the intention to collect all that knowledge and all those resources to solve this problem. And just to give you one more example how extremely complicated it might get. So you have left to right languages, right to left languages, but there's a thing called Old Urdu. I'm not sure I'm completely accurate on every detail, but it's a right to left language where each word is on a little slope. So it looks like this. It's amazingly beautiful, but it complicates your code if you want to do that very much. But you could ask, yeah, who uses Urdu? Turns out that's the fourth most spoken language in the world. So probably if we ever go to India, we will need to support maybe not old style Urdu, but Urdu anyway, which is complicated in itself. So we couldn't do it. That's the conclusion. And we were like a little bit desperate. But then we looked around on the interwebs and found this beautiful little thing called Harfbus. Who heard about Harfbus? There's one person, okay. Two, yeah. Okay, so you're probably using this if you're using Firefox or Linux or have an Android device or something. Because this is the shaping library that is part of the Linux text stack, and also the Firefox text stack. That's a tongue twister. And it's pretty cool. So we have something which has a large user base already. It's in active development. Lots of people from all around the world are working on it. Beautiful, excellent, wonderful, and it's written in C++. So, and we have a JavaScript application to make, right? So not so happy, but I've heard, I think today, that many of you know about mscript10, right? Who heard about mscript10? Excellent. Okay, so mscript10 comes to the rescue. For those who haven't heard, it uses the LLVM compiler architecture, where you compile your source code into a platform-independent bitcode first, which is like code for a virtual machine, and then you further compile and optimize it into native code. So what mscript10 does is, instead of compiling it in native code, it just basically writes the emulator of the JavaScript, of the virtual machine in JavaScript, and it does work. And so we had a beautiful, beautiful system. It was Harfbus.js on the back end, doing all the shaping stuff, so finding out where to put the glyphs in a line, and we wrote all the rest of the stuff on top of it to break it into lines. We wrote the controllers for the input stuff, whatever. So it just worked. It was great. We'll get to Hex soon. So we tried it, and it worked beautifully. The Flash version of the demo application worked beautifully on Windows. The HTML5 version worked on Safari, on the Mac, and Windows Mobile, everything. Great, right? It just works. Perfect, except, and there's always an except, we have the iPad. In the browser on the iPad, it also worked fine. That was perfect, no problem. But we have a native application on the iPad and also on the iPhone. And in their highest wisdom, Apple thought to not give you the beautiful JIT compiler called Nitro that is part of mobile Safari when you have a native application, because it modifies memory and then it runs that memory, so it generates code, and you just cannot generate code on the iPad. So no JIT basically. So it would be slower somewhat than with JIT, right? So just to put it in perspective, we had this wish basically that we wanted to make it so that people, as they are typing, we needed to do the reshaping, relayouting all the time, so it should not take longer than 50 milliseconds or so that they don't experience any kind of lag, so the cursor is not trailing behind. And we managed to do that, so even in Internet Explorer it was like 10 milliseconds at most, so that was perfect. On the iPad, let me demonstrate, it was like you hit a key and then 1, 2, now. There was one letter appearing on the screen. Not very usable for most use cases. So basically we had a beautiful strategy, JavaScript everywhere, that worked on every single platform we wanted to target except the iPad, which is the second most important platform for Prezi. So what do you do in this situation? We were quite far into the project already when this became apparent. So we already, as my colleague Laszlo already explained, we already had quite some experience with Hex, and we knew that it was a great tool to target multiple platforms. So basically after much heartbreak, we threw out the rest of the code, which was written in CoffeeScript, and replaced it with Hex. So we ended up with this. It's a bit complex. So basically what we have is we have a Flash application, and behind the Flash application we have a JavaScript version of Harfbuzz running in the browser, and we have a JavaScript, an HTML5 application, which also uses JavaScript but straight away, and we had the iPad application and the iPhone application where Harfbuzz was compiled to native code, and we just used it with Hex compiled via HXCPP to C++ and then to native code. There was quite some struggle getting this thing right, so connecting the Flash application to Harfbuzz.js. So if you want to push through a lot of the stuff in that remoting tunnel between Flash and JavaScript, it gets painful very easily. So if you have lots of data to push through there, or you want to do a lot of requests, it's probably because of the Flash interface, but it's not fun to work with it. But in the end, we have a solution that works, and I think this is what right now the best thing what you can have right now. This is the present best solution if you want to use JavaScript in your application that you are targeting every platform with, basically no JavaScript. But while we were working with Hex, so it started out for us as a sort of way to do the glue code and do the duct taping of parts together. But as we worked with it, it appeared that alone Hex in itself is a really cool language, and it's really nice to use. So I was just thinking, what would be the ideal world where I could use Hex without the requirement that I need to do this, but how about I could do this and still use Hex and all the other languages to target just JavaScript, and have everything in JavaScript and the iPad included here. And while we were working on this, there was an announcement from Mozilla, and I think it was January, if I recall it correctly, They announced a thing called ASM.js. Who has heard about ASM.js? Yeah, right. So probably this video is not going to come as a surprise to you. If it loads, it loads. Excellent. Can you see it? Or you don't see shit? Oh, we have voice. Okay, how can I have no voice? Perfect, thanks. Okay, so this is the Unreal 3 engine running inside Firefox as just a JavaScript application with WebGL and stuff like that. So basically the target of ASM.js is to run JavaScript as fast as native code, right? They are pretty close already. So they are like at 50% of the native code speed, which is something similar that Java had like, okay, let's enough eye candy. Wait. Stop. 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 Okay. It's very similar to the state of Java like 15 years ago. It was striving to reach the performance of C++ back then, and then it reached it and it surpassed it in some ways. So maybe something similar is going to happen around JavaScript performance. And so why I am telling you all this is because there will be large-scale JavaScript application games. So for one, maybe this is the future of game development. You can target the browser with JavaScript that requires high performance and still make it work. But there's also they are also going to be used in business applications and basically everywhere. So you can expect large JavaScript applications. But to do all those optimizations that the JavaScript compiler needs to do, it takes a lot of time, right? And if you go visit the same JavaScript application every day, like Gmail or something, then it's going to be done again and again and again. And so what Mozilla is doing is that basically the obvious thing that you can save the compiled binary in a cache, and next time you go to Gmail it just loads it, so it's already the optimized binary. But what we could do is we could just take that optimized binary and use it as a binary on the iPad without, so bundle it with the JavaScript engine without the JIT compiler. It's already optimized. The JIT compiler brings the garbage collector, and we have a package, a native binary package that runs on the iPad, with, which stays in the limitations that Apple has placed on us. And on the rest of the platforms, the nice ones, you could still use just JavaScript and code to JavaScript in Hex, in Elm, in CoffeeScript, in Haskell, or even C++, or whatever is your thing. So Hex would need some extra work, I think, to make it work with ASM.js. You don't actually have to have ASM.js support, so this would still work without ASM.js as well. It would just not be very fast. But with ASM.js that would be even cooler. So I present this for your consideration to...
If you go C++, you can do MScript in ASM.js.
Yeah, that's so MScript already supports ASM.js, but for other languages you need to add support for it. And there are some tricky parts where if your language relies on garbage collector, then it's much harder. But maybe Firefox has a solution for that as well in the future, not now. So this is not available now, but in a couple of months this is going to hit your browsers, and I think that's going to open a brave new world for game development and hopefully for Prezi as well. So, well, that's it. Thanks. Any questions? Yeah.
Why did you not port Harfbuzz to Hex to solve this problem?
That was a second idea before, so I skipped that part, sorry. So let me go back. Yeah, so the first idea, when it failed, we also thought that we could rewrite Harfbuzz in another language. It was CoffeeScript, but that was basically out of the question because the code base is so complicated, so difficult. You need so much knowledge about the actual languages to just understand what's going on there that it was not feasible, and it was also under active development, so you would have to keep up, and we didn't want the burden to maintain it. There was also an option to turn it into Flash, you know, Flash CC. That does sort of work, but it's also not ideal, and then we would have ended up with an even more complicated setup than this.
So what about LLVM X backend?
That's an interesting idea. We could definitely make use of an LLVM backend that generates hex code. Do you think it's possible?
I think so.
Let's look into it.
Who want to do that? Excellent. We'll see.
Okay. Any other questions or suggestions, maybe?
Hi. In this slide, you have Harfbus C++ on the iPad, and then later you say you use ASMJS to basically generate another native library.
Yes.
For the iPad. So
yeah.
Why
So
the double translation?
yeah. So yeah, you could ask why do we turn C++ into JavaScript and back to basically C++ again. The whole thing is about bundling all the rest of the JavaScript that we haven't written in C++ together with it so that it works in JavaScript, so we can leverage that on all the other platforms, and then we can still have from one source code. So the main problem with this thing is that it's very, very complicated to build. So there are more components and it gets extremely difficult to build, and with Nicholas we're sort of starting to talk about how we can simplify that. But the major benefit of just having the JavaScript bundle is that your build is very simple, your whole system is very simple, and you just have to add one more step.
Okay, so basically because of all the existing JavaScript code.
Yes, and all the JavaScript code we want to code, so we don't want to code in C++.
Yeah.
I think that's understandable.
I just wanted to ask the difference between OTF and TTF, and why you couldn't use just TTF, or did you need OTF because that's a bit more advanced, is it, or?
So it's a bit confusing, but so OTF, by OTF I mean the open type specification, which is basically bundling type 1 and TTF together and not making any kind of move to make it simpler or make them one standard. So it's actually two standards, and you have to support both of them to, so we support TTF files and OTF files, if that's what you're asking.
I just wondered if TTF would have been enough, or you actually needed that.
There is a slight difference that, well, there's lots of differences, but the major difference is that TTF uses quadratic Bezier curves and OTF uses cubic. So you cannot convert back from OTF to TTF. Well, you could convert the other way, probably, but we just want to use the vanilla font files in our application. We also want to use like Google web fonts, so we just want to be able to point the user to a TTF file and make use of that file.
Did you experiment with HX SwiftMill?
HX, sorry?
Is it HX SwiftMill, the Jan's parser for fonts and stuff?
Not really, no.
Oh, okay, no, it doesn't do everything, but it's,
okay.
Yeah.
I've got one deep question here. Did you bring any palinka?
No, sorry. Next time.
Okay.
Thank you very much.
Thank you.